have lyrics underneath the house?
No, I'm just for a little bit from the side.
Oh, sorry, that's you.
Oh,
You can stop it.
In history class, they literally read like 7 chapters in one day. How do you do that?
Read 7 chapters. You don't. Everything's optional.
it's calling me.
Sorry. So far.
That's Samsung.
All right, first thing, did anybody check the answers on last night's homework? There was homework last night?
Aren't they correct?
Oh, the answers are correct, but
The number 4.
yeah, number 4. What about it?
And
I don't know because you saw it on the board. Number 4, the answer is right, but when I did it, on the video, I misread it. It said the square of the distance from the z-axis.
Yeah.
But I did
But
the distance.
you didn't like fully solve it, right?
Oh yeah, but I changed it on the written solutions. Anyway, so today is the last lesson for this chapter. Now we're going to integrate in the spherical coordinate system. So this is what the triple integral looks like. Rho squared sine phi d rho d phi d theta d phi. You can put it in whatever order you want to. So you know what I think I'm going to do? Look, because on the worksheet there's a picture of a spherical wedge. And you know what? Yeah, maybe I should put that on the test. Like explain why rho squared sine phi d rho d theta d phi is the volume of that infinitely small wedge there. Well, it's kind of easy. Well, here. Because this is theta, right? Remember theta?
Yeah.
Is the angle. So right here, this is d theta, right?
Yeah.
Infinitely small. So d theta, and then if you multiply it by rho, then you're going to get the length of that piece right there, yeah?
Yeah.
You know, why am I telling you this? I'm going to make you explain it on the test, maybe. And then, of course, you integrate over the region, 3-dimensional region. So why don't we just go through a problem then? Let me think of one. A sphere, okay, so find the region bounded by the sphere, x squared plus y squared plus z squared equal, give me a number. Home. A reasonable number.
49.
All right.
Oh, you want the number to come on big? Okay, we'll go with 49. So we got a sphere of radius 7. And then give me an equation of a quadric cone. Learner. Quadric cone. So it's kind of like this, and then the cone is like that.
D squared equals x squared plus y squared.
Yep, that would be it.
Okay, stop there.
Okay. So what is the region bounded by the 2? What would that be? Wouldn't it be this cone and the ice cream on the top then as well?
Yes.
Bounded by both of them? Is that right? Yeah, that's right. Okay, so how can we write an integral that represents the cone and the ice cream on top? Well, look at the equations. When you see x squared plus y squared plus z squared, that's kind of like a hint you should do spherical right there. So here we go. Rho squared sine phi. Okay, now the thing is, you have to change these equations into, or at least this one, into spherical coordinate. So what is the equivalent equation for this in the spherical coordinate system? Rho equals 7, right?
Yes.
So remember, the origin is like over there, yeah? So which one we're going to integrate with respect to first? Actually, this problem is easy because they're all constants. It doesn't matter which one you do. Why don't we go d rho, d theta, d phi? Let's just go in the, why did I rewrite it? We could have just done it right there. So rho will go from what? Hey, wait a minute, that's not even the right graph. That's why we're having trouble. Hello? Here's the sphere. Here's the quadricone like this then, right? Because it goes from the origin. So, okay, now we got the cone and the ice cream on the top. This is the region right there. So rho is going to go from what? 0 to 7, right? Because you're going to go like this, right? So rho goes from 0 to 7. What about theta? Remember what theta is? So if you have, okay, here's the box. I'll draw the box. So here, this is theta, right? So since this thing goes all the way around, then shouldn't the limits of integration for theta be 0 to 2 pi? Go all the way around. So 0 to 2 pi. And then what about phi? Phi is the angle, remember, if this is rho, phi is this angle right here. This is phi. So here's the vertical right there, the positive z-axis. So rho is going to go from, not rho, phi is going to go from here to here. So we have to figure out what that angle is right there. How do we figure out that angle?
Plug it in, find the radius, and then.
What do you mean plug it in?
This,
Find where they intersect.
Yeah, and then find the radius. And then
Okay, so if x squared plus y squared is equal to z squared, then why don't we just substitute z squared for that? So we get 2z squared equal 49. Oh, that's ugly. What would have been a better one? 16, yeah? Oh, whatever. We're just going to go with this. So z squared is equal to 49 over 2. So z is equal to 7 over root 2. Plus or minus. So what does that mean? The z coordinate right here, because the intersection is like a circle, right? So z, this, is 7 over root 2. But how can we figure out that angle phi there? We got to figure out some other things as well.
radius is 7.
Oh, the radius is 7. Oh, we got it then, right?
Isn't just a 45?
So that's a 45, 45, 9 triangle.
Yes.
Can't you just know that because like that line is y equals x?
Oh yeah, that's another. You're right. So this is a 45-degree angle. That's right. So however you figure it out, so phi is going to go from 0. Remember, it's always measured from the positive z-axis. It's going to go to 0 to pi over 4 then. Okay, so shall we attempt to do this integral? I think we should. So if we integrate with respect to rho first, what is this going to be? 1/3 rho cubed sine phi from 0 to 7. But this is a constant, so we should throw it out here like this. Oh, 7 cubed. Who took this number? So sine phi, plug in the top number. 7 cubed, 343.
Yep.
So 343 over 3. And and then minus 0. Okay, now we have to integrate this with respect to theta from 0 to 2 pi, so doesn't that just have the effect of multiplying it by 2 pi?
Yep.
Okay, so we multiply by 2. See, this one's easy because it's all constants. And then now we integrate with respect to phi, but there's no phi here. Oh no, we do. We do have it. So we actually got to do it. 0 to pi over 4. So this is constant. So the constant is 343 over 3 times 2 pi. What's the antiderivative of sine phi? Negative cosine phi from 0 to pi over 4. Factor out the constant. So we've got negative 343 over 3 times 2 pi. Plug in the top number. Root 2 over 2 minus 1, which is negative, which cancels out that negative, yeah? And then you really can't simplify that too much.
No.
Yeah. Anyway, so that would be the volume of that thing right there. So you gotta look for clues to figure out which coordinate system you want to use, yeah? So when you see x squared plus y squared plus z squared, that's a hint to do spherical. When you see x squared plus y squared, that's a hint to do cylindrical. And of course, on the test, everything's gonna be mixed up now. I'm gonna tell you one of the problems. One of the problems, I'm gonna give you a region, and you're gonna have to write all 3 integrals. Rectangular, cylindrical, spherical, and then I'm gonna just say pick one of them to compute. Whichever one you want, whichever one looks the easiest. Okay, so when is the test?
Next week, Tuesday.
Tuesday, extended, right? Okay, we're done.
Oh.
And then, do you know this density thing? That's guaranteed on the test now. So density is volume multiplied by the density function, right? And you integrate over the region.
Oh, it's this.
Huh?
I don't get this.
You took AP physics.
I don't think we did
Density?
in physics 1.
I'm pretty sure.
Mass over volume.
Isn't this like common knowledge?
So wait, density is equal to mass over volume.
Yeah.
Yes.
Mass over volume. So that's why mass is equal to volume times density then, right?
No, but the integral thing, you did like the ratio thing, and then you did like the weird like formulas.
Yeah, because it said like the distance, well, you gotta read, so it's like the distance from the outer shell, or it could be the distance from the origin, or it could be the distance from the z-axis. So, sit down. I can send this video to the administration, you know.
Is it 2 pi because it goes all the way around?
Yeah, because this angle, yeah, because it goes all the way around, right? You know the cone? It's like this here. Here. This is hey, what's this? So here's the positive z-axis, and then this is phi, right? So let's go around, goes all the way around like this, right? Phi is this angle here. But theta is the angle in the xy plane, right?
Let's take a feet, this is 7, right?
First one feels like 4.
Okay, this is 7.
And then you find.
That's why phi goes from 0 to 7.
And then you find this by making like the intersection.
But this
Mhm.
is the.
Oh, but like Mark said, it has to be 45 degrees.
Converting
Why?
R
That would be
divided
important.
No, because of this
R
equation.
dz divided theta.
So it's
Oh.
like, it has to be right triangle. Wait, what?
Because this
So
is,
if this is 7 and this is a 7 over
Oh.
2, that doesn't guarantee that
Right.
this is also 7.
Yeah.
no, it's 7 over root 2.
Yes.
It does.
Right, because in a 45, 45, 90, isn't the
So,
leg,
Okay, so.
isn't the hypotenuse root 2 times the leg?
Is going to be,
What is that?
um, D rho
Because, you know,
times.
look, in a 45, 45, 90 triangle, if this is 7, isn't this 7 over root 2?
Why is it 45, 45?
Rho sine.
Oh, because of part, You mean the Park's explanation? Park, why is the angle always 45 degrees?
The trace, look at the
From-
trace.
Yeah, the trace.
Oh, so the trace,
Yeah, set x equals 0.
oh, so here, okay, here.
Not very good. I don't-
So the cone is like this, right?
What was the-
Right? So how do you find the YZ trace?
Make X zero.
Okay, so if you make X 0, you get,
So the dimensions of that,
so Z equal plus or minus Y then, right?
Yeah.
So doesn't that mean that's 45-degree angle then? The slope is 1, that's why, right? So this is 45 degrees then, right?
What was your,
Huh?
what was your?
This?
so this.
You find where they intersect and that's a 45-45 90 triangle.
Yeah.
Because the hypotenuse is double, I mean not double, but root 2 times the length.
This right here.
That's a property of 45-45 90, right?
Oh, so you don't have to know like this.
Well, you know it's 7 over root 2, right? If you use the
One right here
Pythagorean theorem.
Is like.
Oh, yeah.
2,
Oh, cause the Pythagorean theorem guarantees like this.
right, this is in the z
Like
axis.
that.
No, well, we're just, no, I'm not using that on, I'm just using the regular, just,
Yeah.
not that.
It's fine.
Just use the
This,
Pythagorean theorem.
The,
Oh, so you
And
make it a
this-
right
this-
triangle.
this- yeah, so that third side will be 7 over root 2.
But isn't
But then we really didn't need to do it, because if it's,
Isn't 7 over like this whole thing not?
no, that's 7.
okay, okay.
That's the radius of the sphere.
That's
Oh, I see,
this.
I see, I see.
Yeah, okay, yeah.
Yeah.
Well, how is that an intersection of this and
See, okay, we get it, you have.
Because- okay,
a haircut
so,
with a Samsung. You're-
When you intersect these two, didn't we get z equals 7 over root 2? So that means the z coordinate where they intersect, don't they intersect right here? The z coordinate of this point will be z over root 2, which is that distance there, right?
Like imagine someone
Oh,
reading with a
this-
wheelchair
oh.
outside of your handicap
Oh,
ramp, so. Like you just walk out and just show you.
Hey, we got the video still going, what's going on? Okay, let's play one game and then we're done.
It's getting better.
Hey, what are we gonna do tomorrow then?